Luckily, series and parallel components in circuits is a pretty easy thing to learn. So let's start with a few definitions. So first off, series, all it means is that the same current flows through the devices. Right? And for parallel, all it means is that the devices share two nodes in common. As a consequence of the first property of what it means to be in parallel, you also get the same voltage across the devices. So for example, if you had 5 resistors, all of them in parallel, and they're being supplied by a 5-volt battery, they would all have 5 volts across them. Okay, so let's look at a quick example here. So in this circuit, we're going to look at the nodes here. It's a pretty common misconception to think that the intersections of wire themselves, like these little dots, are just the nodes, and like that's it. And that's not correct. The actual nodes here are entire sections of wire. So here in this circuit, we're going to have 3 nodes. Okay? So here we have 3 nodes. And here's some extra stuff for you. R2 and R3. Okay, well R2 and R3, they share 2 nodes in common, because this node on the bottom and this node in the middle, these 2 nodes are both touching R2 and R3. Okay, so because R2 and R3 have 2 nodes in common, they're going to be in parallel. Right? If we look at V1 and R1, so the voltage source and the resistance, R1. Well, if you had some kind of current in the circuit flowing, like say down here, it goes through V1, has nowhere to go but up, and then towards the right, then it hits R1. So because the same current flows through R1 and also V1, they're going to be in series. So they're going to be in series. So what about R2 and R1? Right? Well, if you look at R2 and R1, you know, they share one node in common. So the one node in common is the one in the very middle here. Right? But again, if the current's flowing, it will split at this junction right here. So the same current is not flowing through them, and they only share one node in common. And to be parallel, they have to share 2 nodes in common. So because of that, they're not going to be in series nor in parallel. So neither. Cool. So let's see if you can actually do this by yourself. Here's a circuit. It's a little circuit diagram. Pause the video and see if you can identify all the nodes in the circuit. So go ahead and pause now. Okay, so hopefully you did that. So the nodes in this circuit is going to be 1, 2, 3, 4, 5, 6, and 7. So again, every single section of wire is one node. So in this circuit there's 7 nodes total. Again, let's look at some of the components. So we can look at, let's say R3 and V2. So R3 and V2. Again, if we had some kind of current flowing in this circuit, going down right here, it would go through R3, down through V1, keeps on going, and the current has not changed in any way, it goes through R4, and then boom, it hits V2. So because the same current flows through R3 and V2, they're going to be in series. So what about, let's do R2 and I1. So you can probably guess that they're going to be in parallel, and you're right. So it's not because they're drawn visually parallel to each other, like it's because they share two nodes in common. Because they share two nodes in common, the one on the left and also the one on the right. So right here, and also right here. Let's do R3 and I1. Okay, so R3 and I1. They share one node in common, and that's it. Okay. So if you look at the current again, current's flowing. Oh, let's do green. Current's flowing. It's going to split at this intersection. So the current through I1 and R3 is different. So they're not going to be in series. So they're neither. Same goes for R5 and I1. So R5 and I1 are neither in series nor in parallel. Okay. Right, so that's it for series and parallel. Yeah, it's just about knowing how to identify the nodes in the circuit and then working from there. If this video helped you in any kind of way, just give us a thumbs up so that other people can also get help from it. And I'll see you next time.